Hello and welcome everyone to this class. In this lecture, we will talk about how to use goal-seek and solver in Excel to solve multiple equations. So first of all, let's talk about solvers. A solver can solve an equation and give us an approximate value for the answer. Now, we can use different solvers, like different methods, or we can use goal-seek to solve multiple problems. Okay, so as you can see, if we want to activate the solver, what you can do is you can go to Excel, then File, then Options, Add-ins. So let's just see that. So if I just open my one, and if I just go to Data, as you can see, this Analyze box has a solver, so mine one is activated. Now, if you don't see this one, you have to go to this File, and then go to this Options. File and Options brings back here. Let's click on Add-ins, and you can see there's a Go button. If I press that, now you just have to click this one. If you click this one and sort of press OK, this button should appear. Now let's just use this solver to solve an equation. So let's just take a pretty simple one. As I said before, you can go this way and use it. So let's just use the solver and solve an equation. So let's have a value of x, and here I'll just say f of x. Now let's say f of x is x squared minus 2x plus 1, which is pretty simple. So let's just type it in. X squared minus 2 times x plus 1. As I press enter, it should show 1, because as I have this cell, the x value empty, it assumes that the value, the x has 0 value, so this equation evaluates as 1. Now if I have some value, assume that I have 10 here. Now this function evaluates as 81. So as you can see, we can put multiple values, and this function will evaluate like that. Now, to solve this equation, we need to know at what x value this function should be 0. And to do that, let's click on this cell, which has the equation, and come here on the Data tab and come to this solver. If you press this, this will show up, this dialog box. So you can see the set objective is the cell B2 that we want to solve. Now, as you can see, there's multiple options, maximum, minimum, value of, as we want to solve the value of 0, because we want to solve the equation. Now it's asking by changing variable cells. Now, what variable we can change to solve this? Now that should be this initial guess of x1. So I'll just press V1, and the rest of them should be pretty much left as it is. And then if you press solve, and you can see it just solved for x equals to 1. The function of x goes to 0. So our value, our solution is x equals to 1. If you want to keep it, just press OK. If you don't want to keep it, you can restore original values. As it's correct, I'll just keep it and press OK. So now this was solver. I'll just rename it to solver. Okay, I just double click on it and rename it. So now let's see how can we do it differently. Okay, we can use goal-seek, and this function will do the exact same thing to solve an equation. Goal-seek is a function. If you know the final answer of an equation or function, then you can know how did it go from the initial value to the final value. Goal-seek will help you to manipulate or evaluate that. Okay, so let's just do the same example that we did last time and see how to use the goal-seek. So I'll just press this plus button. Let's rename it to goal-seek, and I'll do the same, as I'll have x and f of x like before. I'll keep it empty. Let's say x is f of x is x squared minus 2 times x plus 1. So that's and we had a 10 initially, so that's our 81 there. Now, instead of using a solver, we will use a goal seek. How can you find that? So if you go to this data tab and come here, where it says what if analysis, click on that. The second function is goal seek, so click on that, and now you see this dialog box. So the first thing it says set cell, so which cell has the equation or the function. In this case, it is B2. To what value? As we're solving it, it should be set to 0, and by changing what cell. So select the variable cell here. I have as B1, and if I just press OK, you can see it just solved it approximately 1, approximately 0. So our solution is approximately 1. So I'll just press OK, and that is our goal seek to solve an equation. Okay, so that is the basics for solvers and goal seek in the Excel. I just have these things. So as you can see, if you want to use the goal seek, you have to select the cell that has the formula or the equation. If you have only a constant, it will not work on that. So let's just do the problem that we want to solve in this class. So we will have a projectile motion example that we can solve with both goal seek and the solver in Excel and see how does it work. So let's go to that problem. Okay, so the problem says a projectile motion is launched at an angle of 35 degrees from horizontal with a velocity of 30 meters per second. And we will neglect air resistance and assume a horizontal surface. Determine how far away from the launch site the projectile will land. So if we see the animation here, as you can see, the blue ball is actually our projectile. It's been launched at an angle of alpha, which is 35 degrees. And here V sub I is our initial velocity, which is 30 meters per second in this case. And it will go this distance. Here x sub m is our horizontal distance. We have to calculate that. As you can see, the initial velocity vector can be divided into two parts. One is in the x direction as vx, and another one is in the y direction as vy. And then we can actually solve this problem. So to solve this problem, first of all, we need to know how to convert our degrees to radians, because the Excel has a default radian system. And then we will implement these equations to solve, and with the help of goal seek, to solve our problem. Okay, let's go to the Excel now and see how can we actually implement this. So let's just create another sheet here and rename that to, say, projectile motion. Now let's just say given. What is given? Now we have an angle. We have an angle of, say, 35 degrees. We can just type the units here. Let's say initial velocity comma v. I can increase the width a little bit. So initial velocity in this case was 30 meters per second. And then what we need to figure out is the horizontal distance. Okay, so what is the horizontal distance? To implement that, as you've seen from the slides, we need the v of x, the x component and y component. And also we need to implement this equation, which has an acceleration of gravity, g, and also a time vector, t. So we need these to be incorporated in the Excel file. So let's go to this Excel file. Let's just say g. Now, as we have defined the upwards as positive, So we will have g as a negative value, and we know g is like 9.81 approximately meters per second squared. And then we will have, say, v of x, which is the x component of the initial velocity, and v of y, which is the y component or the vertical component of the x velocity. So we know that the horizontal component is v times cosine theta. So we just have to evaluate that. Let's press equal, select this v, and then press times cosine theta. So let's write cosine. Now theta we have in degrees, but we need it to be radians. So let's just type it radians so that it can convert to degree to radian. Now select this cell for the angle. Let's complete the brackets, press enter. Now we have our value of v of x, which is the x component. Now to calculate the y component, which is v times sine theta, let's just select v times sine, and theta is in degrees, so let's put radians, theta, and that's our v of y. Okay, now what we will do is we will implement the equation, which is y equals to vyt plus 1/2 g times t squared. So to do that, we need a time vector. So let's just create a time vector here. Let's just define it that it goes from -5 to 5 with an increment of 1 second. So the first value is -5. The second value is -4. Now what you need to do is just select this 2 cells, come here at the right corner, press, and then go down up to 5, and that's your time series. Now in this cell, in this column, I'll just evaluate y. In this case, we have the equation as follows. So our equation is vy times t plus 1/2 g times t squared. So if we go back to the Excel, so click equal, vy is this one. Vy times t has the value of this one. Now, as you can see, this has multiple values, so this should be a relative reference, and these should be an absolute reference because we don't want the vy to be changing at every step. Okay, so vy times t plus 1/2, which is 0.5, times g, which is this value. Now it should also be absolute, so I'll just press F4 to do that, times t squared. If I press enter, okay, so that's my value at -5 seconds. This should have a value like this. If I just double click on it, it should fill out all those values, and you can see I have multiple values here. Now, so we have the evaluation of this y function. Now, how can we how can we press our initial guess on this? So we have to solve this equation so that this y goes to 0. Now you can see at time equals to 0, it already went to 0. So is it a solution? Yes, it's a solution, but it's called a trivial solution. So we don't want to know a trivial solution because we already know if t equals to 0, then the function is 0. So we want to know a non-trivial solution, which is at t equals to some value other than 0, the y should go to 0, meaning y is the distance. So if the horizontal distance goes to 0, that means the projectile hit the ground, and then we will know the exact time it took for the projectile to go from the first position to the second position, or the complete air time. We can calculate that. So how can we calculate the non-trivial solution. We can already plot these to have an idea, or we can see the values. Now, I'll just select these two columns, and let's just plot these. Like, come here, go to Insert, go to Scatter Plots, and just plot these. As you can see, it went through from 0 at 0, but at some point between 3 and 4 kind of crossed the x-axis, meaning it has a solution for some value between 3 and 4. As you can see from the values too, the 3 has a positive value, but 4 second has a negative value, meaning in between 3 and 4, we should have a solution for t that will satisfy this equation. Okay, so now how can we do that? So to do that, we will need another thing that's called an initial guess. So let's just say initial guess t0, something like that. So in this cell we will have that. Now we have a basic idea about the initial guess, like the solution. It should be between 3 and 4. So let's just put initial guess as say 3. Okay, and press enter. Now we have an initial guess as 3 second, and now we will use the goal seek to solve this problem and see if we can figure out something. Okay, to do that, let's just say okay. Okay, as we were saying, we had an initial guess of 3 seconds. Now let's just write another in another cell. Let's just write t, say here. Let's say t solution of t. Let's just have that, and in this cell we will have a solution of t with the help of goal seek or the solver. So let's just write the equation in terms of our initial guess. So here let's press equal. Now our equation was, as you remember, y equals vyt plus 1/2 g times t squared. So vy stays the same times t, which is now this value, plus 1/2 times g times t squared. As you can see, if we have a value of time t as 3 seconds, it doesn't go to 0, it goes to some value as 7.47. So now we need to make this function as 0. So we can use either the solver or the goal seek to have a solution. So let's just click on this function. Let's go to the data. And if we select the what if analysis, goal seek, and if you can see, it's already asking me cell, so which cell, and it already selected this E9 cell for me. So we need that to go to 0, and which cell it should change? It should change the initial guess, so that at what time this equation goes to 0. If I just press OK, and you can see this is almost 0, so it's just like 3.5. 3.51 seconds or something. So yeah, it's pretty good. I will press cancel because I want to show you guys the other way to do it. So if I just press here, go to the solver, and as you can see, it's asking me this E9 now go to 0, which cell, this one, and everything else remains the same. If we just press solve, and you can see it's just really tiny value of 10 to the minus 6 or something, and it went to 3.51. So basically we have used both the solver and the goal seek to figure out the air time. Now the entire time, the solution should be this one, which is 3.51 second approximately. So as we can see from the calculation, If we know the time, we can use we can calculate this x of m by evaluating v of x times t, v of x times t. So let's just evaluate that. So here we need the answer, so I'll just evaluate everything here because we want to know what is the horizontal distance. So come here, press equal. So now we need to press this Vx and times our solution of t, which is this one. And if I just enter, this is our equation. This is the solution. So if we throw a projectile at an angle of 35 degrees with an initial velocity of 30 meters per second, neglecting air resistance and assuming horizontal distance, it should go approximately 86.2 meters. Okay, so I think that's all we wanted to discuss here. Yeah, so this is the solution. So in case you have any questions or comments, feel free to ask me. Yeah, that's it. Thank you very much for watching. Have a good day. Bye.